So if you think about the motivation behind my work, it lies in the difference of reasoning that we have in our AI systems. And in my case, it happens to be recommender systems, right? Conceptually, maybe we think of this slightly different shapes of concepts or different contours or different colors, but the reality, right, of the way that people reason is rather different in nature in the way that we see in machine learning systems. Now, if we think of that more broadly, specifically in the context of explainable AI, we can think of this as a gap between the explanations that we now can generate and what we as people need in the end applications. And there are many reasons for that, but if we're looking at the state-of-the-art explainable AI methods, especially the ones that are local or post hoc, they're actually not particularly robust. So the kind of issues that we see is that if we try to explain an instance in the data, we get very different explanations. So if we're looking at, for example, feature-based explanations, right? So we're saying, for example, this person gets a job or this mortgage gets approved because of a certain salary. These kind of features can change the rank or even the direction of their importance, right? So they're really not robust. Furthermore, if we try to apply different explainable AI methods on the same instances, we can get very different explanations. Not only that, but if we inject data into the system, we actually see vulnerabilities to adversarial attacks. That can be as extreme as getting a different predictive class, or as these first two instances that I gave, we can get different explanations. And it's made worse, if you like, by the fact that, of course, what we're ultimately trying to do is to support human decision-making. And that is going to be limited by our cognitive limits, and in particular, the kind of cognitive biases that we might hear about, such as anchoring and confirmation bias. It's inherent in all of us, and there are, of course, differences between individuals, such as our differences in knowledge and skill sets. So I am a professor in explainable AI, but actually my expertise lies in recommender systems. So I'd like to be upfront about that and give you a very quick crash course. At least so you have an intuition about what these kind of systems do if you haven't seen them before. Right, so you've probably seen them in the applications as an end user, so that probably helps me a bit in my explanation. Right, so these are systems that make personalized suggestions or recommendations of goods, services, or people. What the user can do is they identify one way or another the kind of things that they're interested in. This can be explicit by a rating, or it can be implicit by, for example, watching a movie in a system like Netflix or Spotify. If they're indicating the interest here in the blobs, maybe turn on the cursor. Right, if they're somehow indicating that the yellow things are the things that they're interested in, the system tries to figure out other things that are similar to infer liking. And this notion of similarity is defined differently for different classes of algorithms, but this is something that is common to pretty much every recommender system out there. Right, so it tries to figure out other similar objects. You'll see that these items are also yellow, and I have on purpose indicated that the notion of similarity could be a little bit flexible, right? So maybe they differ in terms of size or hue. It's a very abstract notion, but hopefully it gives you an intuition. But what it tries to do, of course, from all the possible candidates that are there, is to give them a relative score, and on the basis of the score to rank it. So let's say we have a list here of 4 items, and we only want to present the top 3. So at some point there's a cutoff, and hopefully the cutoff is such that the things that are under the line are the ones that the user also wouldn't be interested in, right? So you can think of it as a ranking and filtering algorithm. Now, when we talk about explainable AI, we also hear the word interpretability. And we also hear different definitions, and I think it might be useful to recall some of these in this context, right? So some people will define it as a degree to which a human can understand the cause. So what actually caused this recommendation? So as we can see in the example from Goodreads, for some reason, reading Harry Potter results in a recommendation of Dostoevsky. Well, that's a cause, right? But another definition might be the degree to which a human can consistently predict the model's result. This is about predicting results in the future. Now, it might be very hard to see the connection between Harry Potter and Dostoevsky, right? So from this extent, it might be difficult to predict the result. On the other hand, if we look at the rubber duck example, if you have one rubber duck, you get other rubber ducks. Well, at least that helps with prediction, even if it isn't a very good recommendation. And you can think about whether we're trying to explain the model or we're trying to explain the prediction. And so this is a distinction that we've seen come in more recent years. Now, what is interesting that in all the definitions that I've seen, at least, the word human occurs. So it's not just about whether we can generate an explanation, but whether the person on the other end can make some sense out of it. So this brings me to the motivation in my work. We see that there are collaborations between people and systems, and many of these are, quite frankly, non-experts. They're not working in machine learning, and they have the benefits of human reasoning, but they somehow need sometimes the help of the systems, right? And there's a potential here in leveraging joint strengths. But these people might not accept advice from systems. And this could be because they don't know which information has been used, or if their opinion is actually considered. So they might have knowledge and they don't know if the system has taken account of that knowledge. So while we have many barriers for technically generating explanations, we actually have many barriers that are cognitive. And so my premise here, and has been for a while, that explanation can help us make better decisions together with the systems. Now, because we have half an hour, I'll cover two aspects that I like to talk about. One is the different purposes that we might want to obtain with explanations, and the other is that different situations call for different explanations. So this is showing my age a little bit, because when I started my PhD in 2006, I realized that people didn't really agree about why we might want to explain recommendations. And so I conducted a literature survey and systematically tried to identify what are the different criteria that people use. And this is the list that came up at the time. And these are very much from the perspective of the end user. You could argue that if you maybe looked from the side of a system designer, this could be different. And in looking over this list, a couple of things quickly became apparent. One of them is that transparency was something that came up, right? And the kind of question one might have here, well, how was this recommendation made? But another question one could ask is, why or why not this item? So helping the person to make a decision. Now, you can be very transparent on how the system works, but it might not actually help with the kind of information that people need for making decisions. Another important distinction is regarding persuasion. Why do we want the person to buy this item or make this decision? Now, this is different from decision support, because sometimes maybe you want to persuade a user not to make a certain action or try a certain item, right? So there might be a distinction here between persuasion and effectiveness. And so in my PhD, at least, I was saying, well, are there trade-offs between these different factors, and when do they occur? So I said, well, we want to help people with decision support. We want to help them with effectiveness. Well, how can we even measure this in the first place? Well, it's actually a workshop paper in 2005 that gave a fairly easy protocol, a simple protocol, that says, well, ask the people for their potential rating of an item. What is your initial impression or plan? Then let them actually consume it. And then afterwards say, well, was this actually a good idea? If at the first step, they already have the explanation, they shouldn't have a big change in opinion, right? So if the explanation is making them think that this is a good purchase, after they try, they also should think that's an equally good one. So this enabled me to compare different kinds of explanations in terms of effectiveness. Now, Forgive the simplicity of the interfaces. If you recall right, this is a few years ago. And I was trying to look at what we could do in terms of commercial systems. So this was a RESTful API where I was extracting movie dimensions or features for movie descriptors. My simplest baseline here that I compared against was whether or not a movie belonged to the top 250 in the IMDb. Right? It is a fairly simple bit of text, but it is one that gives some indicator of quality already, even if it's not personalized. Then I looked at personalized explanations. So if I knew which genres a person liked and didn't like, and which kind of features they wanted to know about a movie, then I could have an explanation that contained these. And I contrasted this with explanations that were non-personalized. Now, it seems relevant to know which genre a movie belongs to, but here I just don't indicate it in relation to the person's profile, and I don't describe a feature that they wish for. This is just a random feature selected. Right. So as you see, these are fairly simple, but they are automatically generated. So this could be done for any movie that was in the IMDb database insofar as the metadata was in place. And so I asked, right, to compare these different dimensions. Is the explanation effective? Is it good for decision making? Is it persuasive? Is the person likely to want to watch it? And is it satisfying? So are they actually happy with the recommendation that they get? And here's what I learned. So I did this for two domains, one which was more objective, a little bit more high cost, cameras, and one which was more subjective, movies, and also lower cost. So to have a little bit of a range here. And I conducted 4 experiments. And time after time, despite my best efforts, for some reason, personalizing the explanations didn't seem to do particularly well, especially in terms of effectiveness. So the personalized explanations were worse for decision support. People were having a strange first impression in relation to what they actually wanted later. However, the really weird thing was that personalization led to more happy people. So they liked the fact that explanations seemed to consider their tastes. If you recall, I also had this baseline. I looked at this IMDb top 250, and that did pretty good in terms of this effectiveness measure, the change in opinion. But I also asked people or gave them the option to opt out. Right? And it turns out that if you give them a very simple explanation, they actually say, well, I can't make up my mind. Right? So this is also important in terms of figuring out if an explanation helps. Well, do they just pick the middle of the scale, or is that really something that they can't make a decision about? The other thing I wanted to talk to you today about was the fact that an explanation might be useful in different situations, or the kind of explanations that you need differ depending on the situation. I'll look at 2 situations. One, when we explain to groups, and the other when we deal with viewpoint diversity. So this is the work conducted by Shabnam Najafian. She is doing her PhD thesis at TU Delft. And she's been trying to figure out how to make recommendations for items to groups when there's actually no single best option for the group. So imagine the scenario. These people are on a road trip. You're a member of the group, and you actually disagree for these 3 songs. So you really like the song with the saxophone, but Carol really likes the drumming the most, whereas Bob likes the violin. So one simple strategy you could do is apply a fairness strategy. You take turns. Right? You go first, Bob goes second, Carol goes third. It's one way to do it, but you can imagine that if the saxophone gets picked first, well, Bob and Carol might not be that happy. So you have to do something in terms of explaining this. And here you could say, well, the system detected you might not like the violins, but it is the song that Carol prefers. So you can help mitigate in some sense that the person's preferences were not taken into account in a certain turn. Now, we also thought about the different situations that occur within a group. So, of course, if you're in a group and you have different preferences, you might be the person that disagrees with the group. Or you can be the one sorry, you can be the person that agrees, but there's somebody else that's unhappy, or you can be the sole happy person, right? So you can be in a low consensus scenario, but you can be either in the majority or in the minority. Or you can have a situation, of course, where everybody agrees. And what we let people do is indicate which information they actually want to disclose. So they could be specific or obfuscate the name, they could indicate the rating or not, or they could indicate the personality of the person or not. And you'll see that these are, for the purpose of this presentation, underlined in the color that indicates the type of information. So we said, how do people control these different toggles in these different scenarios? Maybe not surprisingly, the scenario did indeed influence people's need for privacy, so which information they chose to disclose. And the thing that they were most careful with was the combination of name and personality. The user comment suggests that the reason they don't really want to disclose personality is because they don't know how it's computed, right? So as soon as it's a derived feature, people are much more careful. And we saw that when the minority gets a preferred song, the identity should not be disclosed together with their personality. Shabnam has been doing quite a lot of experiments in this area, and it's also being continued by Francesco Barile, who is now an assistant professor at the University of Maastricht. We've been looking at the role of personality and tie strength, and actually also the level and different types of disagreement that one could have in a group in terms of reaching consensus in a group. The other situation where we might think about needing explanations is when people have different viewpoints. And so this image indicates two people looking at the same thing, but actually seeing something very different. And we look at it specifically in the context of search results. So if search results are biased, there's no variety in viewpoint. This could influence the opinions that people have. And there's a known phenomena, the search engine manipulation effect, which indicates that if the search results are biased, their opinions can be skewed by this. So during online information search, users might also select search results that confirm their pre-existing beliefs or values and ignore competing possibilities. This is a cognitive bias, which is known as a confirmation bias, right? So if you have selective information and you have a human bias, the two amplify each other. And I guess it doesn't require too much of your imagination that you can see here the potential harmful effects that we've seen on individual businesses and society, for example, in the context of elections. Right, so this affects things like health choices, but also online debates and political decisions. So how can we then explain these kind of online searches? So Tim Draws has been looking at, first of all, measuring viewpoint diversity in search results. So if you imagine the kind of question that we have here, should I be vegan? Right, and the kind of formulation, well, you see a whole bunch of results that are positive on top and negative in the bottom. And so this is at risk of a search engine manipulation effect. The kind of work that he's done is looking at how we can represent viewpoint beyond a simple pro-con or even a ternary pro-neutral con label. And this work has actually won a couple of Best Paper awards. He's also been looking at understanding algorithmic biases. So if we use different metrics, how sensitive are they, for example, to underlying distributions? He's also been looking at, well, if we present different search results, at which point might they change their opinion and which factors affect these? So if we can measure viewpoint bias, then we can move a little bit forward in terms of creating the explanation interfaces that mitigate them. And hopefully this image illustrates to you nicely the notion of confirmation bias. We all have friends like that, but I fear that we're also often that friend ourselves. We click on something that agrees with their point of view simply and ignore that there's other contradictory information. So this line of work actually started with roughly 2018. I started as a recommender systems researcher in the movie domain, looking at people's blind spots. So this is things that people don't know that they don't know. So the width of the bars here is the frequency of watching a movie. So these are movies that are only comedy, and then we have bridges, for example, between comedy and romance. Right? These are the rom-coms of the world. Now, these dark ones are the things that are represented in the profile, but you see here, we have a light gray color, and these are things that are represented in other people's profiles that aren't represented in yours. So this particular user watched some drama movies, but for some reason isn't watching movies that are both dramas and thrillers, or both dramas and romances. And we found that showing people their profiles in this way encouraged them to do a bit more exploration. We also worked with a media company in the Netherlands, and we looked at semantic similarity in addition to the frequency of reading a topic. And we also there saw a tendency to explore topics that they hadn't read that much before when given this kind of interface. But it was only an intention. It wasn't actual reading behavior in a deployed interface. And then there was another PhD student that picked this up recently looking at search results, and I'll talk about that in a bit more detail. Right, so Lisa started in August 2020. She's one of our COVID babies in the sense that she started her PhD during the pandemic, which she's actually done really well. She's been looking at the kind of interfaces that we can have to mitigate bias. So if we have our users who are interacting with web systems, right, they might perceive the information that they get with biases because of information overload and so on. Right, there's a lot of information, a lot of choices. At the same time, they give interactions such as upvotes quite quickly, and there's actually very little accountability, for example, also if we share information on Twitter. And these factors together are increasing the cognitive bias of our users, right? These systematic errors in human thinking, leading to suboptimal decisions. So what can we do here in terms of the interface to improve their awareness of alternative viewpoints and their own bias? So we looked at this particular kind of interface. It's an obfuscation, so it hides the search result from the user, and it also makes them aware of their confirmation bias by requiring them to tick this little box. It's not a very complicated interface, but it's we'll get to that in a moment, right? So what it does here, right? So we're hiding it, and that means that we're controlling the information intake. Because they also have to click here to see the search result, it's an interruption. It slows them down. And they were given a task to mark articles for a final written summary, so as a discussion piece later. So they are a little bit accountable for what they actually select. So there are a couple of mechanisms that are in place for something that is fairly simple. So our research question here, can the obfuscation of these search results together with warnings motivate users to interact with search results that are attitude opposing? So things that are different from the opinion they currently hold. So this is really for given their current opinions during search for information on debated topics. We gave them 12 search results for which we knew the viewpoint. It was crowdsourced. And we let them select articles both for themselves by clicking on them and for creating a summary by marking them. So this is a bit of a schematic of the kind of results. If we start with the no obfuscation condition, this is the viewpoint. So it ranges from -3 to +3. And the opposing ones are marked in red and the supporting are marked in blue. So you can see that this is a balanced list in terms of viewpoints, but we also have some very strong viewpoints in the list. Then we have targeted obfuscation. So if we know this person is very strongly in favor, we can obfuscate results that are very strongly in favor. So these are the +2s and the +3s in this list. So these ones have this obfuscation that we saw in the previous slide. However, if they are in the condition for opposing viewpoints, then it's the -3 and the -2 that get marked. And as control, we also created a random obfuscation. So just a certain number of results, not in relation to the viewpoint. We had a reasonable number of participants, and we recruited them via the Prolific platform. The thing we were manipulating, right, was this display condition. We actually also varied the task condition, whether the clicking and marking were joint or separate. There was no major effect of that, but for the sake of completeness, I thought I'd mention that. And what we measured was, did they actually click on search results that were attitude confirming, and did they click on results, did they mark results which were attitude confirming? The results for the two were comparable, so I'll focus just on the clicking. So what we see here is the three conditions: targeted, random, and no. So we're joining together the supporting and opposing. And this is the proportion of clicks that are attitude confirming. So you can see that the intervention was effective for the targeted condition, right? So by obfuscating the results that are in line with the person's pre-existing views, we get them to click on them less. And if we look at the random versus no obfuscation, these two are comparable. So targeted obfuscations effectively decrease the interaction with attitude confirming search results. So we can mitigate here the confirmation bias. This is at least some good news. But what we also see is the obfuscations decrease interaction even when they're applied for random search results. So here we can only compare the targeted and random because it has to do with obfuscated results. And we're saying, well, did people actually click on this button? Did they ask to see it? And we see in terms of asking to see them, this is comparable, right? So this little barrier that we created for interacting with results worked regardless of whether it was correctly marked or not. So it's very powerful, but it's also risky if it's being misused. So because this is very effective, we suggested some ethical guidelines. First of all, this has to be for the user's benefit. It should never be for the system's benefit. It should be with the user's consent, so users should always know what is going on and how it's being used. We should also have explanations that are transparent. And we should have a simple control mechanism so they can decide whether they want this in the first place or not. One thing that we don't know from the study is whether they were actually processing this in some way, or if they're taking the path of least resistance or least effort. Right. So in the coming years, we're looking at fine-tuning this approach. First of all, we want to make sure that the user autonomy is maintained or as great as possible, right? They can be autonomous. We also want to separate the effect of the warning label versus the effect of the obfuscation, because in this study it wasn't completely clear, although it seems like the obfuscation was potentially the main thing. We also want to look at the effects of the task design and user-related factors, so individual differences in terms of how effective the explanations are. In some other previous studies, we've indeed seen big differences between different participants and which explanations are effective. So if we look at her project overall, we're looking at which method of presentation of search results effectively emphasizes viewpoint diversity. And what we're starting on now is which user factors we should model when adapting the mitigation strategies, and then moving on to not just single-shot mitigation strategies, but actual interactions to mitigate the biases. So these are some of the previous projects. Elisa is hired on a EU Marie Curie project. Tim is hired by a project supported by IBM and TKI. And we're also named collaborators on a project with universities in Amsterdam, which are closely related on nudging users towards diverse news exposure. Moving forward, there is a long-term program planned for trustworthy AI in the Netherlands. This has passed the first round, but we are now awaiting the second round of review. So the funding is pre-allocated, but it still needs to be decided by the national funding body. And I am the Social Sciences and Humanities Chair, so facilitating the contacts with our peers in adjacent fields. And we're also planning to participate in a Horizon call on human-centered design, specifically trustworthy AI. We are still on the lookout for industry partners. So if this is something that is interesting for Bell, maybe that's something that we could talk about. I unfortunately couldn't talk about all the wonderful work of all my colleagues, but I do want to just take a moment to appreciate all their hard work. It's a pleasure to be involved with both the University at Delft and Maastricht. At Arcis, working on the NL4XAI project with our colleagues in Aberdeen. It's a European-wide project. So I hope this is an opening to work together. I hope we can have a bit of a chat, but if you're a bit shy, here's my email and Twitter handle. If you found this stuff interesting on, let's say, a meta perspective, we had a piece in the communications of the ACM recently about the European approach to AI from a recommender systems perspective. Also one of the authors of the handbook chapter on explanations of recommender systems, where I talk about some of these things like mitigating bias. But there are also, you'll see quite some references. I'm happy to share these slides later if you want to go a little bit deeper into some of the work. So thanks again for having me, and I'm happy to take questions.